Okay friends, in this video tutorial we'll be talking about electrospray ionization. So let us erase this part. Electrospray ionization. And electrospray ionization, obviously the name is suggesting that it is a type of ionization process. Now we've already discussed about ionization, like hard ionization, soft ionization, and electrospray ionization is a type of ionization. In the source region we can find MALDI. We have already talked about that. We have also talked about electrospray ionization a little bit, but I haven't found that video that much helpful, so I'm making it a little bit more detail about this electrospray ionization in this video. So ESI, or electrospray ionization. Electrospray ionization. Now in this case, the instrument, or the mass spec instrument, simply this is the 3-chamber instrument, very basic schematic presentation. It is slightly modified, slightly changed. Now in this case, what we can see in electrospray ionization is that we are having a source. Obviously, after the source region, what we are having, so let me draw here. This is the source. So here in the source region we will be having an electron gun. So this is electron gun in the source. So this is source region. So this part, let's say this is the analyzer region, and in this region we'll be having detector. Okay, so these are the 3 different segments. Now in this case, electron gun is firing electron, and normally what is happening in case of MALDI, simply we are having our matrix where laser beam it is hitting and molecule of our interest are releasing. But in case of electrospray ionization, what we are producing micro droplets with our molecules. So let's say this is our desired molecule. So let me draw. This is a desired molecule. Say M is our molecule, our desired molecule of interest. Now this M is converted into a micro droplet. How? Let's say this is the M, and surrounding this M, what we are producing different layer. Now this layer is made up with lipids normally, or it can be made up with other type of layers, like this is a hydrophobic type of layer. It can also be made hydrophilic if I use water and other liquid sources. So other liquid components, we are coating our molecule like that, right? Now after coating our molecule with our desired type of liquid substances, what we do is simply push it into this analyzer, right? So simply push it into the analyzer. And remember, in this case, electron gun, after obviously hitting the electron gun, because here we are having the micro droplets. So let's say here we are having micro droplets, and in these micro droplets, many cases we can find electron gun. Obviously many cases there shouldn't be any electron gun. Instead of electron gun, there are other ionization process like chemical ionization. Usually this ESI is connected with this quadruple analyzer. Remember, we have already talked about quadruple analyzer, and in this case, in this ESI process, the analyzer is slightly bit modified, and in this case they usually don't use electron gun. Instead they use chemical ionization process, which is the soft ionization, because the actual idea and the goal behind coating this molecule with this droplet structure and all this thing is that to prevent this particular molecule of our interest from being bombarded with other molecules, so that it is getting hampered. So we don't want our molecules to be getting hampered. So for that reason we are coating it, we are making all these things. Now after that, when it is this is a molecule. After that, after heating of electron or any kind of chemical ionization, it is getting ionized, and what it is producing is simply parent ions or fragment ions and all these things. So it can produce this. It can produce small different fragments or particles. Now whatever particles it is produced, they remain in different clusters. So all of these particles will be coated with all these micro droplets. So they are forming micro droplets. Now these micro droplets will be moved from here to through the analyzer till they hit the detector, right? Now during this movement, what we are doing in this case, we are simply, so in this case, if this droplet hits the detector cannot detect anything because it is already coated by other molecules, right? So we need to get rid of this liquid parts. So for get rid of this liquid parts, here in this analyzer section there are some modifications like we simply put different barriers, different chambers. So let's say this is a chamber, this is another chamber. So this kind of chambers are there, and these different chambers, there are different pressure changes, so let me erase this part and write it. Now in this case what we can see, that suppose in this first chamber, so if this is the chamber number 1, in this chamber the pressure of gas, what kind of gases, like nitrogen gas, and this kind of gas can be there. Now the presence of this gas, as we can see, remember I've talked about that chemical ionization is possible. If you're using chemical ionization using methane or ammonia, we can use them. Now in this case the pressure, let's say here it is 1 torr. In the second chamber the pressure is, let's say, 10 torr, and the third chamber the pressure is, say, greater than 50 torr. So what we are causing, we are increasing the pressure, and obviously we are heating in this analyzer. So analyzer is already heated, and obviously we are increasing the pressure. So as we are increasing pressure as well as heat, what it is doing, these micro droplet structures are literally losing the liquid part, because the liquid part is getting evaporated. So that is a very important point. So this liquid part getting evaporated, right? So liquid evaporation is going on. After that, when it travels through this analyzer and reach the detector, only the particle remains. So here we'll be having only our particles, small particles, large. So it will hit the detector, and then we're having the detection of signal. So this is how ESI actually works. Okay, so it's very simple again, but simple modification so that our molecule is not getting hampered, right? So that's it, and I hope that's helpful. Thank you.